Hey everybody, it's Mr. Wagner back with a flipped classroom video. I want to look at some more difficult equations and how we solve them. So far in class we've been talking a lot about these more simple equations like, for example, 5x plus 3 equals 23. And we've talked about undoing this by doing the inverse operation, and whatever we do to one side we do to the other. I'm doing this quickly because you should be pretty familiar with this by now. And once we get to this point, 5 times x equals 20, so the inverse of multiplication is division. We divide both sides by 5. 5 over 5 is 1x, so we're left with 1x here. And on the other side, 20 divided by 5 is 4. So we know that x equals 4. Now, that's well and good. You should be pretty familiar with those at this point, but I want to look at some more difficult cases today of equations that might not look like this form. So I'm going to quickly delete my board here, and we'll get started. All right, here we go. Okay, so what happens if we see an equation like this? So we're going to say 3 times 2x minus 3 equals, let's go 33 equals 33. A lot of 3's here, I know. But how do we do this? In the order of operations, we have to start inside the parentheses. But as you can see here, we can't subtract 3 from this 2x because they are not like terms. So we have to think back to this tool that we got in our math toolbox back in 6th grade. We've talked about it some this year, and that's the distributive property. Whenever we have parentheses like this with a number outside of it being multiplied, you got to remember when there's a number next to parentheses, that means multiply. We can actually multiply this to both of the terms inside. Okay? So that's how we're going to start this out. And whenever I'm doing any tough problem like this, I like to start off by adding the opposite. It just really helps me out as I do my work. So I'm going to turn this subtract 3 into plus negative 3. And you'll see why that's helpful in a little bit, hopefully. So once we do this, what we're basically doing is simplifying our expression on both sides of the equation. So now we have 3 times 2x. That gives us 6x. And then 3 times negative 3 is negative 9. Okay? And now you notice that we are back to this pretty easy looking equation. All we had to do is simplify that out, and we're back to this kind of two-step equation. So if we're adding a negative 9 and I need to get rid of negative 9, I'm now just going to add a positive 9. So a negative 9 plus a positive 9, that goes to 0, and we're left with 6x here. Now if I add 9 on this side, I have to add 9 over here. So 33 plus 9 equals 42. And as you can tell, I made my numbers nice and neat so that they divide evenly here. So 6 times x equals 42. We have to do the inverse operation, divide by 6 on both sides. 6 divided by 6 is 1x. 42 divided by 6 is 7. So x equals 7. So once again, it's a really easy problem once we do this simplifying or this expanding up here with the distributive property. Now I'm going to show you another kind of problem, and I want to get some more color going here. So what happens if we have a problem like this? Let's say we have x plus 5 plus 3x equals 2x minus 10. So this looks a little bit trickier too, but once again, if we kind of simplify first, let's work on one side of the equation. Let's get all of the like terms together. So can we add x and 5 together? No, we can't. Can we add 5 and 3x together? No, we can't, because this 3 has an x with it. But what we can do is we can add in any order that we want. So let's add the x and the 3x together. Let's simplify this side. X plus 3x is 4x. So now we have 4x plus 5. And on the other side, we already have this as 2x minus 10. So we're back to one of our problems to solve where we have to get all of the variables to one side. This side has x's and this side has x's, just like those bags in class. So let's take them away. I like this whole changing color thing. This is fun. So let's take away the 2x from this side. And if we do that, we have to do the same thing over here. 2x from this side. So now, our new equation has 4x minus 2x, which is 2x, plus 5 equals negative 10. And we are back to that really simple form where all the variables are on one side. So now let's just balance this out. Subtract 5 from this side, and subtract 5 from this side. Here's where you got to be good with your integers, people. What's negative 10 minus 5? Give you a second to think about that. Negative 10 minus 5 is negative 15, because subtracting is the same as adding an opposite. So 5 plus negative 5, we get nothing, cancels out, and we have 2x equals negative 15. What do we do now? Well, we got to divide by 2. And we're left with x equals, remember 2 over 2 is 1, so 1x equals negative 15 divided by 2. 2 goes into 15 7 times with 1/2 left over. So there we are, everyone. Those are just a couple examples of some trickier problems. In this one, we had the distributive property we had to worry about before getting into our equation. And over here, we had like terms we had to combine before getting into solving our equation. And I know I talked pretty fast here, but the great thing about a video is you can pause it, replay it, see if you don't understand something, and you can always ask me in class for more help. So I will leave this video at that. Watch it tonight, and I will see you tomorrow for some practice. Have a good one, guys.